Hi, it's Professor Monty, and we're talking about multiplying rational expressions. So remember, rational expressions are just fractions. So just like our fraction rule from before, recall when we multiply fractions, we just multiply straight across. So multiply the numerators, multiply the denominators. Essentially, that's the idea of multiplication. Now, a lot of times we would multiply and then reduce or simplify. What we're going to do often here is we're going to factor first, then reduce, and then we're going to multiply straight across. So I like to do it this way. If we multiply first across and then try to factor and reduce, it's going to make things a mess. But if we factor first and then reduce, remember, there's the same factor on the top and on the bottom, things being multiplied, we can cancel them out to 1 and then multiply across. Let me show you an example. So here we've got an example. Remember, if I've just got a regular fraction, if I didn't have this here at all, I could say, oh, the x to the third and the x to the fifth, I can reduce that straight up and down. One's numerator, one's denominator. They're all being multiplied. I don't need to factor this. These are already factors. They're already being multiplied. 16 multiplied by x to the third. Well, I've got 3 x's on the top, 5 on the bottom. If these 3 cancel, we'll put a 1 there. Not an x to 1, just a 1. They're going to cancel 3 of these. I'm going to get an x squared. Now, we can also, since this is all going to be one numerator and this is going to be all one denominator, I can cancel kind of diagonally also. The idea is if something on the top is the same factor as something on the bottom, for instance, 4 goes in here once, goes in here 4 times. So on the top here, I have 4 times 1. 3 goes in here once, 3 goes in here 3 times. That's the idea. Now I've fully factored. There's nothing else I see that I can factor out or reduce. So now I'm just going to multiply straight across. 4 times 1 times 3 is 12. 1 times x squared times 1 is just x squared. If I could further reduce this, I would. I can't. So that's my answer. That's fully simplified. I've multiplied and simplified. Not in that order. I factor, reduce, multiply. Same thing here. Now I've got a bunch of stuff going on. A lot of stuff can be factored out. So let's see. The x squared minus 4, that's the difference of 2 squares. That's x plus 2x minus 2. This one down here, I can factor out. X times x, giving my x squared. I need 2 numbers that multiply to negative 2, add to positive 1. Well, that's going to be positive 2 and negative 1. Now, don't fall for this. Don't try to say, oh, those 6's cancel because they're the same thing. This 6 is not a factor. It's being added or subtracted. It's what we call a term. I can't even cancel this 3 with the 6 because it's only multiplied by x. It's not multiplied by everything else in the denominator. Okay? So don't confuse. Don't think of this 3 as a factor, even though it's multiplied by the 3x. For the denominator, the 3x is a term. And I can't cancel a piece of a term or an entire term. I'd have to be able to factor out a 3 first. Well, I can in fact factor out a 3 first. So I'm going to leave the 6 on the top. I'm going to factor out the 3 on the bottom, and it leaves me with x minus 2. Now everything's fully factored. Now this 3 and 6 can reduce. I can say, oh, 3 goes in here once, goes in there twice. But what about this x plus 2? Those cancel. That's just a 1, and I usually don't write it there. The x minus 2's cancel. That's another 1. But when I multiply by 1, of course, it doesn't change anything. So all I have left on the top is 2. All I have left on the bottom is an x minus 1. And that's my answer. So that's how we multiply rational expressions. We're going to multiply them straight across, but I'm going to factor first, then reduce, then multiply. It'll make it a lot easier to get to the answer.